Hello guys, in this video we are going to discuss about thermal instability and thermal resistance. We know that the collector current for CE configuration is given as IC is equal to beta IB plus 1 plus beta into ICO. Let this be equation number 1, and IC is equal to ICO by 1 minus alpha plus alpha IB by 1 minus alpha. Let this be equation number 2, and this is that the change in temperature also affects the operating point, that is ICO doubles for every 10 degrees Celsius rise in temperature. The collector current causes the collector junction to rise its temperature. Hence, ICO increases simultaneously and IC also increases, which in turn increases the temperature. So the transistor output characteristics shifts upwards because IC increases. Then the operating point changes. So in certain cases, even if the operating point is fixed in the middle of the active region, because of change in temperature, the operating point is shifted to the saturation region. And when talking about the stability factor S, if IB is fixed, the operating point shifts with change in the values of IC with temperature. From equation 2, ICO is doubled itself with every 10 degrees rise in temperature. IC also increases with temperature and IB is fixed. The operating point is shifted in order to keep the operating point fixed. IC and VC should be kept constant. There are two techniques to keep IC constant. We already know the two techniques, that is the stabilization technique and the compensation techniques we have discussed in the earlier videos. Where the stabilization technique has the resistive biasing circuits are used to vary IB by keeping IC relatively constant with variations in ICO, beta and VBE. That is, IB decreases if ICO increases to keep IC constant. When talking about the compensation technique, in this method the temperature sensitive devices such as diodes, transistors are used, which provide compensating voltages and currents to keep the operating points constant. Now talking about the thermal resistance theta. The thermal resistance is denoted by theta and can be expressed as theta is equal to Tj minus Ta by Pd, where Tj is the collector base junction temperature and Ta is the ambient temperature of air around the transistor and Pd is the power dissipated. Generally, for high power transistors, its value is 0.2 degrees Celsius per watts. It acts as a proportionality constant in the equation Tj minus Ta is equal to theta Pd, where Tj minus Ta is directly proportional to Pd. Hence, the thermal resistance value depends on the difference between the junction temperature and ambient temperature, that is Tj and Ta. If this difference is high, then the thermal resistance becomes high. So that's all about the thermal instability and thermal resistance. In the previous video, we have already discussed about the thermal runaway, which is important, and we have discussed the conditions for thermal stability too in the previous video. And thanks for watching.